Before the 19th century, routine practice for dental pain is extraction of the tooth once pulp exposure encountered. Attempting to treat the tooth was by applying of arsenic drugs that would necrotize pulp tissue to reduce pain. The assumption that an insertion of a sharp wire within the tooth can clean and widen the root canal would lead to ease of patient pain started in 1838, when Edwin Maynard used the ground watch spring as an instrument to clean the tooth from within. This practice documented and shows to be successful and opened the door for a whole innovative dimension in the field of dentistry. Primitive files has no standard measurement and were made of carbon steel. They were very stiff and often cause canal transportation and root perforation, but anatomical studies such as his 1912 aid in better understanding of root canal system which affect the way of file design. Kerr in the beginning of the 20th century gained its reputation for being the originator for what's called K-type file and reamers. The name endodontic file wasn't established till the year 1921. The term endodontics was first proposed by Harry Johnston 1921. In 1928, he created the first practice limited to endodontics in Georgia, US. 1943, AAE formed and the name was adopted. In Sweden, Gustav Hedström, 1869, thought the K-file wasn't efficient enough and the design can be better, but not until 1940, Sendoline Company was able to create a machine capable of manufacturing H-file. Prior to 1959, endodontic files were not manufactured according to any set standard. That is, the size, shape, and overall configuration varied from manufacturer to manufacturer. John Engel, a professor at the University of Washington in the United States, first proposed an instrument standardization in 1955, and Levine followed after in 1961. In 1976, the American Standardization Association authorized Specification Number 28, which outlines the requirement for the production of files and reamers. In 1981, following 26 years of research, Specification Number 28 final standards were made public, and at that point, the instrument's current international standardization was established. Grounding and twisting of a blank wire result in these features. First, taper, the increase in file diameter with each millimeter along the working surface. Cross-section, the mass of the file is determined by the geometric shape it presents when sectioned perpendicular to the longitudinal axis. Flutes, the area of the file where dentine chips and soft tissue extracted from the canal wall and collected. Rack angle, this angle in the cross section is created by the file radius and leading edge. It can be positive or negative. Helical angle, the angle created by the file longitudinal axis and the cutting edge. Finally, we have the pitch, the separation of corresponding location where the pattern does not repeat. Despite the sophistication that has been reached with file design and manufacturing, errors such as transportation and perforation and file separation are still an issue to the practitioners. Academic community tries to find a solution to such mishap by modification of a new technique such as Ron's balance technique or in the file design Frank Wayne 1975, who advocated using a fingernail file to remove the blades on one side of endodontic file that would reciprocate against the outer canal wall between a curvature and apex to avoid zipping the canal, a design known today as a safe-sided file. In 1988, Walia proposed the use of nitinol instead of stainless steel file in his famous article that titled Initial Investigation of Bending and Torsional Properties of Nitinol Root Canal File. The article grasped massive attention in the endodontic community, and the era of rotary nickel titanium file begins. The first nickel titanium rotary file was patented and introduced by John Max Baden in 1993. Despite suffering of many weaknesses, it paved the road to other inventors to adjust the design to be more flexible yet more resistant to torsion that cause file separation. In 1994, William B. Johnson introduced nickel titanium file with taper exceeding 2% taper. Profile initially comes with 4% and 6% taper. It's meant to be used in a crown down technique in 3 simple steps that reduce operator time, adapted of K-type triangular cross-section with radial land that increase performance safety by scraping of the dentinal wall instead of cutting. The critique was that the need of several files to complete the task. In the year 2000, Buchanan introduced the concept of variable taper, where the diameter of the root canal increased progressively toward the coronal third. This design offers several advantages over traditional rotary file with fixed taper, including improved cleaning and shaping efficacy, reduced risk of instrument breakage, better adaptation to the natural anatomy of the root canal. In the year 2001, Dr. Mashtu, Dr. Riddle, and Dr. West introduced a sprue taper that had no radial land for improved cutting efficacy, reduced working end to 14 mm, multiple taper to overcome taper lock phenomena, but transportation and the straightening of the root canal was always noted. The surface treatment of NiTi files involves several processes aimed at improving their properties and performance. These processes can be broadly categorized into 3 main groups: mechanical finishing, chemical treatment, and thermal treatment. The color of NiTi files after heat treatment is a result of the formation of a thin titanium oxide layer on the surface of the instrument. Thickness and composition depend on the temperature and duration of the heat treatment. M-Wire offers several advantages over conventional NiTi instruments, including higher strength and wear resistance, improved flexibility and cyclic fatigue resistance, enhanced cutting efficacy. There are several popular rotary file systems utilize M-Wire technology, such as Profile GT series, Vortex File, ProTaper Next, Reciproc, and Wave 1. In 2008, Ghassan Yared published an article describing the use of F2 shaper of ProTaper Universal System in reciprocating motion. The clockwise and counterclockwise movement would reduce the incidence of torsional fracture by taper lock. The first commercially available reciprocating rotary file is generally credited to be the Wave 1 Gold file, launched by Dentsply Sirona in 2010. In 2012, NiTi wire with R-phase was introduced. R-phase is a distinct crystalline structure within the nickel-titanium alloy. It arrays when the nitide alloy undergoes specific heat treatment protocol and exhibits unique properties compared to the conventional austenite phase. In the same year, Micromega introduced RevoS file feature, an off-centered cross-section where the geometric center was displaced from the rotational axis. The design offered several advantages: improved canal cleaning and shaping efficacy. The off-centered design created a snake-like movement that facilitates better debris removal and more efficient shaping. In 2015, FKG Dentire launched the XP Endo Shaper and the XP Endo Finisher files, the first commercially available instrument utilizing the MaxWire technology. The introduction of nickel-titanium file has transformed endodontic therapy, enabling operations that are now safer, more effective, more predictable. These amazing tools keep getting better and better, with increased cutting efficacy, fatigue resistance, and flexibility. We may anticipate even bigger advancements in the future thanks to continued research and development. And thank you.